Thermal engineering is an important part of mechanical engineering comprising thermodynamics, fluid mechanics and heat transfer. The knowledge of these topics are helpful in design and analysis of thermal systems, which deals with transfer of energy and mass. Hello everyone, this is Dikshit Kumar. Welcome to DEEMECH and you are watching Introduction to Basic Concepts of Thermodynamics. We will cover the following topic under this video. What is thermal engineering? We'll define thermodynamics, defining heat engine. Also, we will define thermodynamic system and the terms associated with it. Thermal engineering is specialized subdiscipline of mechanical engineering that deals with the movement of heat energy and transfer. The energy can be transferred between two medium or transferred into other forms of energy. We all know that energy can neither be created nor be destroyed, though it can be transferred from one form to another. We all use heat in our daily life and this heat energy can be transferred into other forms of energy. As shown in this example, the heat is transferred through radiation into the vessel. The vessel on heating containing water boils to a particular temperature and converts into steam. There are various types of heat transfer as shown in this example, that is conduction, convection and radiation. Thermal engineering is all about studying the heat energy flow and the transfer of mass. Also, thermal engineering is the study of various different kinds of energy which can be transferred from one form to another. In short, thermal engineering is nothing but study of heat energy. Let's look into the application of thermal engineering. First, we have boiler design. In boiler, the water is heated under pressure to a particular temperature to generate steam. Water is transformed into steam and this steam is used as working fluid in various industrial applications, largely the food industry. In the steam turbine, as shown in the figure, the steam generated from the steam boiler is made to flow through turbine, causing rotation, which is coupled to the generator to generate electricity. Here, heat energy is converted into mechanical energy and mechanical energy is converted into electrical energy. Next, we have combustion engines. All the modern day vehicles have internal combustion engine. Here, the fuel is burnt inside piston and cylinder to generate heat, and this heat is converted into mechanical energy by means of piston cylinder arrangement. In the internal combustion engine, the chemical energy is converted into heat energy and heat energy is converted into mechanical work. Application of thermal engineering helps to design the engine carefully so that the heat and work transfer takes place safely. Study of heat transfer will help the engineer to select the correct material and the components. Cooling systems. Heat generated inside the engine cylinder should be dissipated to the surrounding. This can be done with the help of proper cooling system. As shown in the example, we have a simple air cooling in the right side, which is used in two-wheeler. On the left hand side, we have a radiator system which use air and water as cooling media, which takes away the heat from the system. The excess heat can damage the system, so the effective cooling system is very important. In engine, the maximum heat energy should be converted into mechanical work. Though there will be some losses, an engineer should design the engine component in such a way that the maximum heat is converted into mechanical work, so that the efficiency is increased and whatever heat in the form of losses should be dissipated properly into the surroundings. Next, we have heat exchangers. Heat exchangers works on a simple principle of heat transfer, where the cold fluid from the one end is fed through the pipe system into the heat exchangers. On the other side, warm fluid comes out. Now this happens because of heat exchange between the warm fluid and the cold fluid. You can see here, warm fluid is fed into the pipe and this will exchange the heat and causing the cold fluid to warm. During the process, the cold fluid becomes warm and the warm fluid becomes cool, and this cooled fluid comes out through the pipe outlet. Heating, ventilation and air conditioning, in general it is called as HVAC. The temperature inside the building or automobile is maintained. It is done by heating or cooling. Depends on the surrounding temperature. If the surrounding temperature is hot outside, inside temperature is to be maintained low. And if the surrounding temperature is cool outside, then the inside temperature need to be increased. This heating and cooling can be done by proper ventilation, by using a heater, air conditioner or ventilation. An engineer working on HVAC need to understand the heat flow principle, thermal conductivity and resistance of materials. Process fired heaters. In some industrial application, the temperature of the process fluid leaving the heater need to be maintained at a particular temperature. If the temperature falls due to some reason, the control system calls for more fuel to burn, which will generate more heat and thus maintaining the desired temperature. In this particular industrial application, the engineer need to understand the concept of heat and temperature. He should be well aware about the system temperature and the surrounding temperature. Also, the mass transfer of the fuel to be maintained properly. We will learn the concept of mass transfer and temperature in the coming units. Solar heating. In this application, the solar energy, that is the radiation from the sun, is converted into heat energy, and this heat energy is used to boil the water in the tank. This is the common application, and to design all the components required for the solar heating, an engineer must understand the heat transfer concept, that is conduction, convection and radiation. Thermal insulation. When heat transfer need to be reduced between objects of different temperature, thermal insulators are used. As shown in the example, outside of the wall temperature is higher, that is 40 degrees centigrade, and because of the insulation over the wall, the temperature is reduced to 20 degrees centigrade on the other side of the wall. The reduction in temperature is because of the insulation provided outside the wall. To study the heat transfer between two objects of different material, we need to understand the heat transfer principle along with the different material, its thermal conductivity, resistance, etc. We will be learning all these concepts under heat transfer unit. Thermal power plant. In thermal power station, heat energy is converted into electricity. There are different types of thermal power plant which works on a simple principle of energy conservation, converting one form of energy to another form. Now, let us move to thermodynamics. Thermo means heat, dynamics means motion. In general, thermodynamics is nothing but heat in motion. In given example, we can see the heat flow. Heat always flows from higher gradient to the lower gradient, that is from higher temperature to the lower temperature. To understand heat, work and temperature in the coming part, let us denote heat with capital Q, work with capital W and temperature with capital T. Thermodynamics is a branch of physics that deals with heat, work and temperature and their relation to energy, radiation and physical properties of matter. Given is a piston cylinder arrangement. The working fluid enters with low temperature and because of combustion, heat is generated at high pressure, causing the movement of piston. This in turn convert the heat energy into mechanical work. What do we study in thermodynamics? Generally, we study about heat, work, different forms of energy, gas properties, gas process, process feasibility, that is whether the process is possible or not. Let us understand what is a heat engine. Heat engine is a machine which converts the heat energy into mechanical work or vice versa. This means Heat can be converted into mechanical work, and also mechanical work can generate some heat. In this particular example, heat is generated because of the friction between the gear teeth. Let us move to the last topic of this video, that is thermodynamic system. Let me draw a system. Here, system is nothing but working fluid enclosed in a boundary. It has a definite area. Let us define a system now. System is defined as amount of matter contained in a boundary. A matter may be a gas or vapor. This means the system is comprising of working fluid. The working fluid can be gas or vapor. The layer enclosing the system is known as boundary, or we can call it as system boundary. The system boundary may be rigid or flexible. That means it could be fixed one, or the boundary can expand. Whatever the matter outside the boundary is called surroundings. The working fluid transfer heat. The working fluid can also be defined as liquid or gas that absorbs or transmit energy. To summarize the thermodynamic system, whatever the matter inside the boundary is called system. In the system, the working fluid transmits or absorbs the energy. The layer enclosing the system is called system boundary, and whatever matter outside the system boundary is known as surroundings. Usually the surrounding is air. Let us understand the thermodynamic system with the help of IC engine. Given is 4-stroke petrol engine, here working fluid, that is fuel plus air, enters the cylinder. At high pressure, the heat is supplied through a spark which ignites the working substance, causing heat and explosion, which will push the piston downward, in turn converts heat energy into mechanical work. And the left out heat, which is not converted into work, is made to pass through exhaust to the surroundings. With this, thermodynamic system can be defined as area or space where some thermodynamic process takes place. It is the region where transformation of energy or mass to be studied. Let us see some examples for thermodynamic system. In olden days, we had external combustion engine, or it is called steam engine, where steam is the working substance. Then we have IC engine, that is internal combustion engine. All the modern day vehicles are run with IC engine. The working fluid can be gas fluid, for example petrol engine, diesel engine, CNG, etc. Refrigerator is also example for thermodynamic system, where heat exchange takes place resulting in cooling effect. We have a vacuum cleaner, and also we have an air compressor where air is compressed from low pressure to high pressure. Let us now recall the topics which we have learnt in this video. We have learnt what thermal engineering is. Thermal engineering deals with the movement of heat energy and heat transfer. Then we have defined thermodynamics. It is heat in motion. Later we have defined a heat engine. Heat engine converts heat into mechanical work and vice versa. At the last, we defined a thermodynamic system and the terms associated with it. Thermodynamic system is the region where transformation of energy or mass to be studied.
Open your web browser. In the address bar, type deemechkvgp.wordpress.com. This will open DEEMECH web page. Or you can follow the second method. Just go to google.com. In the search option, type DEEMECH and press enter. This will show you the DEEMECH web page with the name of the creator, Deekshit Kumar UR. Click on this page and it will open DEEMECH web page. If you are using a mobile phone, then simply click on menu button, that is the 3 horizontal lines. You can find all videos related to basic thermal engineering in the online courses page. Click on Basic Thermal Engineering 1 5 MA 4 to T for 4th semester mechanical engineering to explore all the contents.